Hello everyone, myself Apur Tripathi and I am doing my internship at Exposys Data Labs. So basically my task is to build a diabetes prediction using a machine learning. So let's get started with the introduction. So what is diabetes? So basically it is a chronic disease that affects how your body processes blood sugars, and it can lead to serious health complications if it's not managed properly. So why there is a need to predict diabetes? So early detection can help in managing the disease effectively, and machine learning can provide an accurate prediction based on the patient's data. So this is about the company. So Exponential Data Labs aims to solve the real world business problem like automation, big data and the data science. And the famous quote about the company is that our discoveries are beyond the belief. And if you are with us, you will discover a newer way to think. So this is the project overview. So our objective is to build a machine learning model that can predict the likelihood of a diabetes based on patients' data. So data sets which we are using. So we are using the PIMA India's diabetes data set from Kaggle, which contains around almost 768 samples with including 8 features such as glucose, body mass index and age. The next part is the data exploration. So the key steps involved here is we load the dataset and check for missing values, analyze the distribution of features using histograms. We will visualize the correlation between features using a heat map. In sites, there is no missing values, but some features has zeros. That is glucose and BMI that we were replaced with the mean. So we will discuss it further. So data preprocessing steps. We will replace the zero with the mean for a specific column, for example glucose and BMI, and we need to split the data. So we will split the data such that training data is acquired 80% and in the rest data we will perform the testing, and we will scale the feature using standard scaler. So why there is the need of scaling? To ensure that all the features contribute equally to the model, we will do the scaling of the feature. Next comes the model building. So we will use some algorithm to build a model. So first is the logistic regression, support vector machine, random forest, k nearest neighbor and naive Bayes classification. And we will also evaluate the metrics using the evaluation metrics, which will be helpful in calculating the accuracy by predicting the correct percentage of the data. Next comes the model comparison. So the previously we have discussed about the algorithms. So we will use the highest accuracy given algorithm. So the random forest will give us the highest accuracy, which is around at most 78%. So basically logistic regression and SVM also performs well, but we will use the random forest due to some pros. So why we use random forest? It handles the non-linear relationships and avoids overfitting. So it is basically avoids overfitting, which will help in reducing the variance. Next comes the GUI for predictions. So what is the GUI? GUI is basically a user-friendly interface so that the patients can input the data and get the prediction. So we will use 8 features for the input fields such as glucose, BMI and age, and also have a predict button to predict or display the result. So now comes the demonstration part in which we will show you the live demo of the project. So I will show you the project in which I have made a diabetes prediction. So now we have to make the diabetes prediction model. So to make the model, we need to set up an environment. So we will require Anaconda Navigator. So I will teach you how to download the Anaconda Navigator. So here you will write Anaconda Navigator. So from this Anaconda Navigator, you need to click on here. Now you will be redirected to this page. So from here you need to click on free download button. Now you need to skip the registration. From here you will be redirected to the download button. So for Windows you need to download from here. For the Mac and the Linux you need to download it from here. So click on, so the download will automatically start. So I already have the Anaconda, so I am not installing, so you need to install it. After that you need to run the Anaconda navigator. After running the Anaconda navigator you will be redirected to this type of interface. So from here we need to write our Python code. So we will use Jupyter Notebook. So we will launch the Jupyter Notebook. So after launching the Jupyter Notebook, we will be having this type of interface. So in this we need to go on new Python 3. So our Jupyter Notebook is now open, and in this we can write our diabetes detection code with the help of machine learning. And from here you can change the name of the file. You can notice a diabetic detection, and here you can write the code for diabetes detection. So if you want something to be the heading, so you can write a double hash, and from here you can change it to markdown. And now just click shift plus enter, and you can see this is now our heading, diabetes detection. And I have already written the diabetic detection code, so I will be redirecting you to the main code. Now let's start with the main diabetes detection program. So the first step is to import the required libraries. So the required libraries are the pandas. So pandas are used for basically data manipulation and the analysis. We will use NumPy for the numerical computations, Seaborn and Matplotlib for the data visualization, scikit-learn for the machine learning tasks like splitting the data, scaling and model evaluation. And the second step is to load the dataset. So we will load the dataset from the PyMyNDS diabetes dataset from the Kaggle. So I will show you how to download the diabetes dataset. So right here, Kaggle diabetes dataset. So now we need to click on the diabetes dataset. From here we can download the diabetes dataset. So let me show you how the diabetes dataset will look like. So it is somehow our Excel sheet. So as you can see, there is the pregnancy column, glucose, blood pressure, skin thickness, insulin, body mass index, diabetes prediction function, age, outcome. So outcome is basically in the binary form, zeros and one. So one indicates that you have the diabetes, and zero indicate that you don't have the diabetes. So now let me get back to the code. So after downloading the data, you need to provide the path for the data in this section. So now let's jump on to the third part, that is the data exploration. So first of all, we need to check the if whether the we have loaded the dataset or not. So for that, we need to print the first 5 rows of the dataset, and then we will print the missing values, and we'll print the basic statistics of the data, as you can see here. So here's the explanation also. So we will display the first 5 rows of them to understand the dataset structure. After that, we will check the numbers of row and the column, and missing values. If there are any missing values or null values, we will use the missing values. Now in the fourth step, we will visualize the data. For the visualization, we have histogram, correlation heat map, and the pair plot selection feature. So this is the histogram feature for the code for the pregnancy, glucose, blood pressure, skin thickness, and the insulin. This is the correlation heat map, and this is the pair plot of the selected feature. So here's also an explanation. So histogram is basically the visualization of the distribution of each feature, and correlation heat map, which will help us to identify the relation between the features. Pair plot, which will explore the relationship between the selected features and the target variables. And step 5 is to the pre-processing of the data. So we'll pre-process the data. So we will handle the missing values by replacing the zeros with the mean for the specific column. Training test split data. So we will divide our data set. So 80% data set will be used for training, and the rest 20% we will use it for the testing purposes. Feature scaling. So we will standardize the features to have a mean of 0 and a standard deviation of 1. Now we will build and evaluate our model. So for building the model, we will use different machine learning algorithms such as logistic regression, support vector machine, random forest, k nearest neighbor, naive Bayes classification. So here you can see this is the confusion matrix, precision recall, F1 score, and the support. So here's the explanation. So logistic regression, it is basically a linear model for binary classification in the form of true or false. And support vector machine, SVM, it is a powerful classifier for linear and nonlinear dataset. A random forest, it is an ensemble method to improve the accuracy. KNN, that is basically k nearest neighbor. Naive Bayes, the probabilistic model based on the Bayes theorem. And in the special case of naive Bayes is that it assumes that each feature is conditionally independent. Now the seventh part is that we will compare the model, all the models that are logistic regression, SVM, random forest, and KNN naive Bayes. So after visualizing the model, we will save the best model. So as you can see, we will save the best model. So the best model is the random forest model. So till now we have trained our model, and now it's time for our model to perform testing. So for the testing purpose, we will move towards the step 9, which will help us to create a GUI interface. So the first steps is that we will import the required libraries. So these are the some of the important libraries which we need to import to handle the data and make our prediction. So now our process is to load and save the model and the scalar. So we need to load the train model and the scalar that were saved during the training phases. And after that, we need to define the prediction function. So basically prediction function, we need to define the prediction function so that we collect the user input from the GUI fields and converts the input into the data frames, scales the input using the saved scalar, make the prediction using the loaded model, and displays the result in the message box. So now we will create a main window in which we will create the main window for the GUI and set its title. And after creating the main window, we will now create the input and the label fields. So this is the input field: number of pregnancies, glucose level, blood pressure, skin thickness, insulin level, BMI. All these are the input fields. After that, we will create a predict button. So this is the code to create a predict button. And after that, we'll run our program. So let me show you. So when we run our program, this type of interface will pop up. So let me enter the detail. So number of pregnancy, let's say it's 1. Glucose level, blood pressure, skin thickness to be 24, sinew level let's consider as 0, body mass index is 22.5, diabetes pedigree function as 0.5, and let the age be 21. So now we'll predict the model. So the output is that you are unlikely to have the diabetes, and the probability is that you will have 6% chances. So thank you so much for watching the video, and if you have any questions or suggestion, please comment down. And if you want to connect with me, you can get in touch. So this is the email address and the social media. Thank you so much.